Yeah, yeah.
Right.
Wow.
Yeah,
It's written today.
it is. I planned ahead.
What number is this?
5-5.
Shut up.
Some of this will be review of pre-calc in the log section from pre-calc, which I know you all love. And the rest of this stuff will be new stuff. So we're going to talk about how to take, well, this lesson is simply looking at equations that have a constant as a base raised to a variable. So we did that already when we talked about e to the x, and I'm sure you all remember the derivative of e to the x is e to the x, and the integral of e to the x is
E to the X.
e to the x. Good. And if you take the derivative of e to the u, you get
E to the U. Plus C.
That's my job. Don't take my job.
what happens when it's not just x. What do you have to do?
Chain on.
Chain on. Good. So the derivative of e to the u would be e to the u derivative of u, or u prime if you prefer. So we're going to look at something like a to the x. So we start with a little definition here. That's a to the x is equal to e. Whoops. Times the natural log of a. So we're going to need that as we start working through this lesson. I take a constant, or we're not going to use c, we're going to use a, representing a constant, so it's some numerical value, and we're raising it to a variable, which is x. That's the same thing as taking e raised to the x natural log of a. Does this statement make sense? Do you understand how I got that? No.
No.
Okay. This is the same thing as e raised to the natural log of a to the x, is it not?
Yeah.
Okay, because e to the natural log of anything is that anything. And then I used the natural log properties and took that little x and moved that guy out in front. Okay,
Okay.
we're good?
Sure.
Beautiful.
Sure.
You're easy, Tyler. Change of base. This is pre-calc stuff. Now let's do natural log. We commonly use natural log in the definition there, but it doesn't have to be natural log. It could be any log. It could be just log. It could be log base 7. It could be log base 431. It could be whatever you want. But we like natural log. And I hope you all remember that natural log is the same thing as log base e. Good. Whereas log is the same thing as log base.
Time.
You were just waiting for that one, weren't you? Were you like shaking with anticipation?
I gotta show my worth as my first day in this class.
I understand. Were you afraid we're gonna kick you to the curb? We still like. Thanks, Eric.
We already lost someone. She's already gone.
Let's put a roll 10 minutes. You guys are weird. Prelacy.
Emma's out.
Shut up. This is the definition of the class. You're just
If you take a constant and you raise it to log of the same base as that constant of something, you'll get that something. Which is a little ambiguous, but you see that that cancels with that and leaves you with just x. Oops.
Is it low shade today?
Yeah, wait. Underneath the mouse, what is?
Oh,
that?
that's log base a of
Oh,
x.
okay.
Sorry. All right, any guesses what that's going to equal? Log base a of a to the x?
X.
X. Why? Wendy?
Because it cancels.
It cancels, correct. Log property, move the x out in front. Log base a of a is 1 times x. Okay, so I don't think, none of that is new, right?
No.
Well, it shouldn't be new. It might be new. But you may have forgotten it. All right, what happens if we want to solve, let's change colors here. What happens if we want to solve the following problem?
Is that a 2 or a Z?
Log base 2 of x. How long have you been in this class?
Well,
2 z.
it looks like a Z. Thank you.
Z.
I heard
Z.
it from somewhere.
7.
All right.
7 that I forgot to add the bar.
Well, then maybe it's a Z you forgot to add the bar.
I don't forget on z's. Nor 2's. Are we good now? Can we move on? Good. How do you solve that?
2 to the -6.
I'm sorry?
Well, you put like a 2 underneath the log, and then you do it to both sides, so it's 2 to the -6 power.
Excellent. Approach number 1. Put a 2 under here, kind of like the E2 trick that we used before. There's no elegant way to describe that other than you just taking one side and raising 2 to that power and then taking the other side and raising that to that power. What's the left side become? X. And then this, I'm assuming you, whoops, that's a 6. I'm assuming you can do that. What's a negative exponent do?
1 over.
1 over, so that would be 1/2 raised to the 6th power. Okay, that's one way to solve it. There is another way. How else can you solve this equation? Whoops, that's a 2. That's a 2, not a z.
You sure?
Yeah, well, I started writing something different.
It looks like there's a dash there.
Oh, for God's sakes. I'm going to stab you with this pen, Tyler.
It's not the first time I've heard that.
I just threatened you on tape, by the way. What is it, a 2? Yeah, it's a 2. Don't confuse me. How else can I solve that? To be honest, most of you are probably going to use the first technique, either the E2 trick or the 2 raised to the trick, whatever that base is. So that was an 8, you would have 8 to the blah, blah, blah equals 8 to the -6. However, you could also refer back to the original idea of converting between exponential and logarithmic forms that you did back in pre-calc, and that is the base raised to the opposite side equals the thing that you're taking the log of. So 2 to the -6 is equal to x. This seems a little bit easier initially. However, this in the long run will prove to be a more practical way to solve those types of problems. What are we mumbling about? Okay. Are we good? So that's all pre-calc. Let's do some calculus. Let's take the derivative of a to the u. I'm going to give you the formula first, but I think in this case it's important to see where this formula comes from. And we're going to put a box around that. Actually, we're going to put a rectangle around that. Geometry teacher. Because that's important. Unless you want me to put a box around it. I'll put a box around the next one. So the derivative of a constant raised to a variable or a constant raised to a function is itself, just like e to the x, times the natural log of that constant, chained on with the derivative of the thing up on top. Now the reason I'm going to show you the derivation, not the derivative, the derivation of this formula is because it might help you remember it. If you just want to, guys on the roof. Sorry.
Squirrel.
I'm easily distracted.
Squirrel.
Yes, exactly.
You gonna wave again?
Yeah, you always wait.
You have to go.
Oh, I
wave.
can, yeah, sure.
Wait, you always not gonna wait.
me they have their hood. Oh, wait. Never mind, they're fascinated by the garbage truck. Where were we? Oh, the derivation of the Okay, so we'll just do a to the x because it's a little bit easy. Whoops, that doesn't belong there. All right, well, so the derivative of a to the x, and that would be the same thing as the derivative of that initial formula we had, which is e to the x natural log of a. Okay, those two things are equivalent. We start with that original, very first thing that I gave you on the first slide, and said, okay, let's take the derivative of both sides. So this side is just going to stay the same because that's what we're working towards. We're going to manipulate this guy. How do I take the derivative of that? This you should be able to do. We've done that before. What's the derivative of e to the anything? E to the anything. That really hurt my knuckles. Times derivative of that thing. What's a derivative of that thing? You're overthinking this.
It's the same thing.
Natural log of A.
Thank you. Natural log of a. Why, Emma?
Because the derivative of,
Oh.
it's just the same. You know what I'm saying?
I do, 100%, but I'm not sure that they do, and I'm concerned about their learning. So if you could explain it a little bit better.
I think you're gonna explain it.
You think?
Yeah.
What is it? Yes, Frank.
Is it because natural log of a is a constant?
Correct. The natural log of a is a constant, and constant x, derivative of 2x is just 2, so the derivative of a constant times x would just be that. Okay. Now, what's the difference between, oh, we're not done actually. What's this equal to? How about if I rewrite it this way? Does that help? Okay, so that's where the formula comes from. Now, what's the difference between what I have in the rectangle and what I have over here is that instead of using just an x, I used a u. So that could be another function, so I would have to chain on the derivative of that function. Okay, that's where that du dx comes on, so that's the chain. Again, if you want to remember the derivation of that, or if you just want to put it on a note card and memorize it, either one. The more you do problems with this, the more it'll burn into your brain, and you'll be okay with that. Let's take the derivative then of, whoops. The natural, or no, log of AU. And that's going to be equal.
Is it 20?
Who's 20?
Crap. Airplane mode, here we go. Group chat's what you can do about it.
First world problems, bro.
Airplane mode's on.
Awesome. Thanks. Okay, so the first one is a constant raised to a variable or a function. The second one is taking the derivative of a log now with base a. Again, just a formula that you probably just want to memorize, add to a note card somewhere. That u is in the denominator, and then the du dx is the chain of that u. Okay, so let's take a look at some examples. For those of you that can't read that, that's 12 raised to the 6 plus 3x squared power. And we want to know the derivative. Are we talking about what's in the blue rectangle or what's in the red rectangle? Blue, good. What's A? 12. What's U?
6 plus 3x squared.
Good. So if you're a memorizer, which in this case you might want to be, I'm not a huge fan, but you might want to be, it now becomes a matter of plugging and chugging. So the derivative of this thing is going to be following this formula. So what's A to the U? Yeah, it's what we started with. Itself times natural log of A. What's A?
12.
And what's du dx?
6x.
Good. We okay with that? There's not much you can do to simplify that bad boy. If you can, do. If you can't, don't.
Are we gonna have to take a second derivative?
You might. Wouldn't be that bad, right? Just a little bit of a product rule there. 12 won't, the natural log of 12 won't matter, it's a constant. You want to? We can, it'll be fun. No? I would, if you're gonna take the derivative of this again, I would rewrite it, put the natural log of 12 out in front, consider it a constant, and then do product rule. Derivative of the first times the second plus the derivative of the second. You can take the derivative of, why do you look like I'm asking you to jump out of a window? You can take the derivative of that, right? Can you take the derivative of this?
Yeah.
Yeah, I would hope so, we just did it. Right, so then that's why I said it wouldn't be that bad. And you know the product rule, right?
Yeah.
All right, you're golden. Last example. Going back to basics, what are the two things we need for the equation of a line? Point and a slope. Do we have the point?
Yes.
Yeah, I gave you that. How do you find the slope?
Derivative.
Derivative. So find the derivative of that, then what? Plug in the point, get the slope, write the equation of line. Go ahead. Take the derivative of that thing. What's A?
3.
What's U?
X.
Okay. What's du dx?
1.
1.
So you're just plugging points? Or plugging the x or no?
What's the derivative?
1
1
over
over
natural log of 3
natural log of 3 times
times
x times 1, but we don't need to write that then. Okay? So therefore, for this particular point, we get 1 over 27 times the natural log of 3. Two options. If it's a calculator portion of a test, then you would plug that into your calculator and get a decimal equivalent of about
3? No? I don't know what it's saying It just said
I thought so. You said it so.
You just
Maybe if I said
jumped
it.
on the bandwagon with Grant. Come on, everybody say it.
Can you write it as 1 over natural log of 81?
0.04
The natural log of 81?
3
What?
times 27.
No, it'd be 3 to the 27th.
I just realized it would be no
Well,
over.
Or you're just multiplying by
What?
Cause it's 1 over.
Why
Yeah,
does
but
it,
natural log's never greater than.
I'm sorry?
never mind, why does it get raised to that?
Yeah, each
Log property, number on the front can be moved in there.
Yeah, but it go, like, you're just, well, technically, it was like, just multiplying. Okay.
What's the answer?
0.041.
0.041. Or if it's a non-calculator portion of the test, then you would just put this in as the slope. So we would get y minus 3 is equal to 1 over 27 times the natural log of 3 times x minus 27. And leave it in that form, don't simplify it, because if you screw it up, you'll lose points. Yes, sir.
So you wouldn't want us to just do x minus 27 over 27 natural log?
You mean move that up on the top? You can if you want, it doesn't matter. That's not a deal breaker. There's an integral component to this that we're gonna wait on till tomorrow, because I don't want your brains to melt. So the homework tonight, I think I split it up as derivatives and integrals. You might get a couple of integral problems on tonight's homework. If you do, obviously just skip it and we'll pick up where we left off tomorrow. Okay? Okay.